Hello, everyone. Good afternoon, dear authors and invited guests. Welcome to Technical Session 8C. Myself, Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Solistic LLP, it's my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2024, Jaipur, India. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held a day before yesterday in Jaipur, India, and the virtual event is being held through Zoom yesterday and today, that is 20th and 21st December 2024. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for their presentation and 2 minutes for question answer. On 7 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, then you can write it to me in the chat box. So before getting forward, I would like to introduce you with today's session chair, Dr. Dushyant Singh B. Rathod. Dr. Dushyant Singh B. Rathod is an esteemed professional currently serving as professor and head of department in computer engineering at Ahmedabad Institute of Technology. He brings a wealth of academic expertise to his role, accumulating 11 years of dedicated teaching experience. Dr. Rathod complements his academic achievements with a robust industrial background, boasting 4.2 years of valuable industry experience. His commitment to both academia and industry position him a well-rounded leader in the field of contributing significantly to the education and development of aspiring computer engineers. I request our respected session chair, sir, to kindly address our participants.
Thank you, Karthik sir. I am really very thankful to the committee members of the conferences, especially the main person of the conference. And one more thing that is very important. So all the participants, please, you can present yourself. It is not about the criticize, but it is about just the knowledge sharing portion. Fine. So each and every participant must present their work over here, so we can share the knowledge from my side and from your side also. Okay, so best of luck, all of you. So now, sir, we can start.
Yes, sir. Thank you,
Yeah,
sir, for such
yeah,
kind and motivating words.
yeah.
Let's move towards the first presentation. For the first presentation, I would like to call Nehar for the paper title Advancement in Task Automation for Operating System, a review of language agent frameworks and self-directed learning. I request the presenter to kindly proceed with their presentation. I request Nihar to kindly proceed with this presentation.
Yes, can you hear? Am I audible?
Yes, sir, you are audible to us.
Yes, actually, I'm just like opening the presentation.
No problem, sir.
Actually, it is telling me to rejoin the Zoom, quit and reopen my system for sharing the.
Sir, you can just rejoin.
Yeah,
Till that, we will love to move towards the next participant. Like you have 2 minutes if you can do it in that time. Otherwise, you have to move to the next participant.
hi. I hope it's now visible.
Yes, sir, it is visible to us.
Okay, so can I start the presentation now?
Yes, sir, you can proceed.
Okay, so now we are seeing a shift in the assistant stage. So with the development of language models, people are relying more and more towards this to act as an assistant. But now what is happening, that we can interact it through language means. So we can give it a prompt and the system generates prompt back. But the next stage is agents. agents that can interact with the operating system on your behalf. We are developing such a system that can interact with the operating system and can act as your companion. So our OS based task automation is built on top of the project that is Open Copilot, which provides a framework that leverages operating system to and operating system and interacts with it so that it can perform tasks on its behalf. So the problem is today that uh, users are performing tasks on the high level, but they need some kind of assistant so that repetitive tasks can be easily delegated. So the user, that is the computer user, can focus on high level tasks and allocate the rest tasks to the operating system assistant. So mainly let us go through the architecture. So as you can see, the user will type in a prompt in the command line interface. The prompt will be analyzed, and there are three types of memory: the working memory, the file directory structure memory, and the RAG. Let me tell you about each one. The working memory is the current memory uh, which will act as a memory between tasks. The file directory structure is important to manipulate the operating system and the file directory structure. And let me tell you about the RAG framework that we are introducing in the system. So RAG is retrieval augmented generation. So oftentimes a user has some clue about the task, has needs to query his documents that are present at the operating system. But currently what he does is, because of the lack of the automation tool, he has to search each document for the things that he's looking. So retrieval augmented generation by us will index local files such as PDFs, Word documents, and everything that can be indexed. So those indexes can quickly be retrieved by the language model, and the uh, results that we are looking can be can be quickly uh, retrieved. So basically in our system we are moving towards an OS companion. Today when you are performing some task, you are supported by a lot of uh, tools such as like but these tools, they are not AI, so you won't feel the human touch. But we want to integrate language models to give the user a human touch so that he can perform the tasks in a more simpler way and focus on more high level tasks. So this is our UML diagram that you can see. The user starts the CLI, queries it, the tasks. So the user interacts with the computer system through the graphical user interface. But the question is, how will the language model interact with the language model, or agents interact with our operating system? It is done by our system, by our toolkit that we are making. So generally the task manager, sorry, the task assistant will has a certain set of tools in its repository. So one such tool can be, index RAG, that is retrieval augmented generation. One such tool can be web scraping. So these tools, they are at the OS task assistant's disposal. And plus tools, but plus there are some tasks for which tools aren't already in the repository, for which it can execute code. So how it executes code? First, it generates the code, and then it looks for the right kind of environment to execute it. For example, if the task is related to simple currency conversion, it can use a simple Python script and execute the code. It will write the code, and it will break down the task, write code, and then execute it in the Python environment, which our system will provide. So here is our activity diagram. The user will give a prompt. Um, the prompt will call the LLM. The LLM will decide whether to call a tool or to execute a code. Depending on that, the output will be displayed, evaluated, and errors will be calculated. Errors will be errors will be evaluated, and depending on the errors present, it will iterate on the task that it's doing. So it will be a little more error proof. So the system that we are building, that we're moving towards, is divided into three parts. One is the planner, the executor, and the evaluator. The planner breaks down tasks. So, for example, if I want to, write a script for web scraping, it will first uh, go to the internet. It will search which are the sites that I want to scrape. It will break down the tasks in the planning stage, and then in the executor stage it will execute each of those tasks, and the in the evaluator stage it will evaluate whether each of the tasks has been performed correctly. So that's how we are building an OS companion that will help you, that will help the user in a lot of ways. I believe that's it. So thank you.
Thank you, sir. Now I request session chair, sir. Sir, do you have any questions?
Hello.
Yes, sir.
Okay,
Sir, do you have any
Nihar.
questions?
Yeah. How the task is going to be allocated through the operating system, and what about the execution time?
Okay, so this is a research that we are performing. So you are asking how will the task will be performed, right?
Yes. So
Okay.
which can be allocated by the operating system or manually?
Okay, so what kind of task that we are looking? What kind of task that it can do? So there are some redundant tasks that every user does. So let's take an example of a programmer, because I am a programmer. So the one of the most redundant, or you can say a low level job, is to manage the installation of dependencies, um, for if I want to write a Python script, first I need to check whether the Python is installed. Rather than doing it manually, installing Python, I can directly ask the my OS companion or copilot to do those things. It will break down the task. For example, if it wants to check and install Python in my system, it will first break down the task. The task will be first to check whether Python is installed. It will go, it will write a script to check the Python installation. So the command is something like pip version. It will type in the terminal.
Okay, Nihar. Fine. Thank you. Nice presentation.
Thank you, sir. Now we are
Yeah.
moving towards the next presentation. For the next presentation, I would like to call Karodya Kunj for the paper title Bridging Traditional Techniques and AI-driven Approaches in Image Deconvolution from Classical Approach to Cutting-Edge Techniques. I request the presenter to kindly proceed with their presentation. I think presenter is facing some issues. Let's move towards next presenter. For the next presentation, I would like to call Jyoti for the paper title Building a Digital State Strategic Role of Information Technology in Advancing E-Government Services. I request presenter to kindly proceed with their presentation. For the next presentation, I would like to call Venu Madhav for the paper title Development of an AI-powered garbage detection system for environmental sustainability via YOLO V5. I request presenter to kindly proceed with their presentation.
Hello everyone, I am audible.
Yes, sir, you're audible to us.
Let me share my screen. 1 second. You are able to see my screen?
Yes, sir, your screen is visible to us.
Okay. Yeah. Hello everyone, myself Venu Madhav, and today's my paper title is Development of AI-powered garbage detection system for environmental sustainability via YOLO V5. And my co-authors are Lakshmi Narasimha Raju Mudunuri and Praveen Kumar Maraju. Coming to the content. This is my content, and I will just move on to the abstract. So coming to YOLO V5, so the YOLO V5 model for the garbage detection. 1 second. Yeah, YOLO V5 model for the garbage detection. The system leverages the YOLO V5, a state-of-art. It's a real-time object detection neural network specially utilizing the YOLO V5 nano model, which is adapted to detect the garbage. So datasets customization for model training. Custom data sets were iteratively used to overcome the challenge of the model convergence and improve accuracy. So the integration of machine learning operation pipeline automates the data collection processing, model training and testing, enhance the development efficiency. So optimized for edge devices, the model captures real-time video metadata, supporting efficient trash collection. The system aims to improve waste management practices and contribute to environmental sustainability through AI-driven object detection. Coming to introduction. So this particular research addresses the significant gap in the computer vision applications by developing a garbage detection system using YOLO V5 to enhance urban waste management. Its streamlined machine learning operations pipeline was implemented to automate the data collection, processing, model training, and testing, making the system efficient for real-time edge device deployment. Major challenges including model convergence issues due to inconsistent garbage definitions and difficulties in classifying certain objects and as a trash. Custom datasets with 1,000 to 1,600 images were used for training, but the scarcity of labeled datasets specific to garbage detection made the process challenging. This system also faced difficulties in real-world applications due to variations in the garbage appearance and blockage in urban environment, where trash often mixed with the non-garbage items. RBI detections were the versus image classification. Object detection identifies the it will locate the multiple objects within an image by generating boundary boxes and label, while image classification assign a single label to the entire image. So advanced techniques were used to identify the garbage based on the pixels to the same object class, while instance segmentation identifies individual objects within the same class, improving the object understanding the detection accuracy. Recent advancements in object detection, particularly through the deep learning, have significantly improved accuracy and expanded its application across fields like medical images and autonomous driving. Coming to this YOLO V1, coming to the initial stage of YOLO V1, initial one-pass detection and classification, to YOLO V5, focus on speed and accuracy. Each version introduced significant improvements such as better feature extraction to identify the objects and faster processing and advanced boundaries box prediction techniques. Progression from YOLO V2 to YOLO V8 involved architecture enhancements like PANet, SAMBLAC, CIOU, loss of function, more accurate object localization and classification, especially beneficial for the real-time applications. So coming to theory background, YOLO V5 features a backbone, a neckbone, and a head, making it ideal for the real-time applications like garbage detections. So YOLO V5 is a lightweight application, and it is efficient architecture, especially YOLO V5 with the nano variant. It is specifically designed development on the cutting edge devices such as smartphones, IoT sensors, and low power systems, and its small model size and low computational demands. So PyTorch algorithms used to implement this one. Unlike previous YOLO versions built in darknet YOLO V5, it's implemented in PyTorch, offering greater flexibility to ease of use, import adaptability, custom data sets, and diverse applications. YOLO V5 automates the anchor box generation process using k-means like clustering, optimizing the boundary boxes for any data sets, enhancing its object detection capabilities, particularly for complex tasks like garbage detections. This V5 offers variant ranging from the ultra-light YOLO V5 Nano to larger YOLO V5 Large, allowing the developers to choose between the speed accuracy based on the specific computational requirements for the application. Coming to implementation part, so the main challenges initially we faced was identifying the trash when the trash is mixed with other trash items like glass, plastic, and trash cans. So we used advanced techniques and transfer learning using the YOLO V5 model pre-trained on COCO datasets was employed to improve the model ability to identify specific type trash, despite in pre-trained models focus on 80 different classes. So custom datasets created via RoboFlow. RoboFlow was used to construct and augment datasets tailored garbage detection. The iterative creation process involved refining boundary boxes, improving the pre-processing steps, and minimizing noise in the data through various attempts. The model performance was evolved using precision, average precision, mean average precision, and intersection over union, with focus achieving the convergence to stabilize the performance metrics across the training runs. So over 17 distinct datasets were created to optimize the model training. Early attempts to suffered from issues like large boundary boxes and noise, but later iterations focused on individual trash types and enhanced data augmentation strategies to improve the model's detection accuracy in real-world scenarios. So the training protocol specification, the model was trained over 100 opposed to 320 to 320 by 320 pixel images. Batch size was 32 and single class label for trash. The training used stochastic gradient descent optimizer to minimize the loss functions. YOLO V5 Nano architecture consisted of 270 layers, 1.77 million parameters, and required 4.2 G-flops for a single image forward pass, reflecting the model's lightweight design, optimized efficient computation. So pre-trained weights were imported from external source within 343 out of 349 items successfully transferred, enabling the model to leveraging prior learning and speed up training convergence. The datasets include 700 images, 100 validation images, 200 test images are labeled with the class of trash. Training was performed on Tesla Tesla T4 GPU with 15 GB RAM, with each model run taking 33.4 minutes to complete. After training, the model size was reduced to 3.8 MB by removing the optimizer, achieving fast inference time of 2 batches per 3.38 seconds, making the suitable real-time deployment edge devices. Results. Training results and key performance metric. After 17 reruns, the best precision score achieved 70.3 with garbage V10 datasets, followed by 66.4 with garbage V5. The focus was precision and mean precision. Conclusion and future directions. Primary objective: the study successfully adopted with YOLO V5 for real-time garbage detection and resolved model convergence issues, demonstrating the model effectiveness and detecting the trash. So while this model showcase promises, further improvements in precision are necessary to enhance overall performance, accuracy, detecting the garbage. So future work on edge integration. The next step involve deploying the model on edge devices and cameras, optimizing it for real-time use of practical scenarios such as urban waste management. Camera collaboration and integration. Future research will be focused on the setup and collaboration of cameras, as well as their integration with edge devices to ensure optimal data capture in the process. Meta collection and storage. The study outlined plans to develop systems for collecting the storage image data, metadata, which will be essential for improving the model's accuracy for further development in automated waste management solutions. And these are my references. Thank you very much. If you have any questions, please.
Thank you, sir. Now I request respected session chair, sir. Sir, do you have any question?
Yes, sir. Yes, sir. Very nice presentation given by you. Just I wanted to ask only one thing. You have used, I think, YOLO model. Fine. So what are the other models are there?
So actually, YOLO V5 model we used, like,
Okay.
and there are like V1 to V8 and recently V10 models, up to V10 models are available. But compared to previous versions, like YOLO V5 was more accurate. And coming to this image processing, we use the RoboFlow, which will identify the objects with accuracy, and it will label the
Yes,
object.
yes.
So
Yes,
that's the
yes,
beauty
yes.
of YOLO V5.
Okay, okay. Thank you, sir. Thank you so much.
Thank you
Thank
very
you,
much
sir.
for the opportunity. Thank you.
Now we are moving towards the next presentation. For the next presentation, I would like to call Rahit Sindhi for the paper title Examining AES Cryptography, Evaluating the Impact of Various Coding Styles and Techniques on the Avalanche Effect. I request the presenter to kindly proceed with their presentation.
Hope I'm audible.
Yes, sir, you're audible to us.
I'm so sorry. I'll just reshare the screen. Yeah, that's fine. Good afternoon to respective dignitaries present over here. My name is Rahil Sanadi, and my paper is entitled with Examining of AES Cryptography, Evaluating the Impact of Various Coding Styles and Techniques on the Avalanche Effect. These are my respective teammates and authors who have helped me throughout this project. So going forward with the introductory part, The advanced encryption standards was developed by NIST in 2001 and is widely used for symmetric encryption algorithms, which was being lately replaced by data encryption standards as it had very low security compared to the AES standards in the symmetric cryptographic algorithms. AES is basically a popular option for protecting various types of sensitive data with different key sizes, like for 128-bit, 192-bit, and 256 bits, and have the ability to encrypt a data of 128-bit block. So following with the working process in the AES, we have four processes in a particular round, following by subbytes, shift rows, mix columns, and add round key, which is four primary changes, which guarantees a high level of dispersion and confusion while encrypting the data. During the key expansion process, which creates several rounds of keys from the original key and arranges the row-wise into 32-bit word, where each bit of word can be consolidated into 8 bits. One word is equal to 8 bits. So into 4 words, we have consolidated into 32 bits, which is a crucial component of AES. While changing any AES key expansion and transformation can help us both improving the performance or security due to the altered data dependencies and diffusion properties. Sorry. So heading towards the basic understanding of working of AES-128, how we have collaborated it. So basically the implementation process of AES has we have inculcated into a multiple coding style, which is a row wise as a column wise, as I've discussed in the earlier slides, where changing the variations will affect the performance and the security level as well. So the start is a very good strategical part to approach for studying of AES cryptography. While we are inculcating the EES algorithm process with high sensitive data using the transformations like subbytes, shift rows, mix columns, and add round key for its robust encryption. The first basic method, the encryption method, starts by a zoring purpose, where it is zored with the plain text by providing the particular key at the first round, followed by the consecutive rounds, total of 9 rounds. After the 9 rounds, on the 10th round, we are just omitting the mixed column part due to its obtaining of the output section. Once the AES encryption begins, we have to subbyte the transformations, which introduces the non-linearity and confusion during the encryption process. Once the non-linearity and confusion is been entitled, next we are matching it with the SBox loop database, where replaces each byte of the state matrix, which is given as into 4 into 4 grid. Basically, the subbytes is into the formation of 4 into 4 grid. And when we are comparing it with the SBox, and SBox has a matrix of 16 into 16, which has a substitution values, which strengthens the resistance of differential and linear cryptanalysis. If any attacks has been occurred or any cryptanalysis has been performed, it helps to provide more advanced and secure process during the output, ensuring minor input changes, whatever input changes has been made, leads to a significant ciphertext variations, which is basically an avalanche effect, which we'll be discussing in the further slides. Now, as you can see in the diagrammatical part, we have taken the cipher key of 128-bit. This is the key expansion, which I was discussing in the previous slides. First is the add around key, followed by the first round consists of the subbyte, shift rows, mix columns, add round keys, where it has been processed and made more advanced and keep on making the data encrypted in advance, so that it creates more confusion and very secure type of encryption process. At the last but not the least round, after the ninth round, there's no mixed column, so that where directly the add around key is been zored with the word process and provides with the ciphertext. As you can see, the subbyte process, this process can be formed into 4 into 4 grid of matrix, which has been compared with the SBox to provide a different or new subbyte formation for the next round process. So heading forward towards the shift rows, mix columns, and add round keys for discussion. In AES, we have the shift rows transformation, to keep the first row unchanged. Basically, we keep the first row as unchanged while cycling, shifting the second row, third row, and fourth rows by 1, 2, or 3 bytes respectively. First row is being kept every time unchanged, then followed by the respective rows. We are being shifting it by 1 byte, 2 bytes, or 3 bytes, right? And if we want to shift by column transformation, we can achieve the similar diffusion effect by just shifting it to upwards. While row, we are shifting it from left to right, and towards the column section, we are shifting the bits into upwards direction. Where the next process of mixed columns transformation improves the diffusion by treating each column of state matrix as a polynomial of Gauss formula, which is 2 raised to 8, and multiplying it by the constant matrix modulo. It has been a mathematical formulations and an irreducible polynomial function, which has been provided. But last but not the least, for the particular round, in the add round keys transformation process, we are rounding up the key as just making the XORing process by the state matrix to obtain the particular output for the particular round. Then the similar process has been carried out for each and every rounds, right? As you can see over here as well, the shift columns has been inculcated by 1, then 2 bytes, depending on columns, different columns. Similarly for the rows as well, first we are shifting by 1 byte, followed by 2 bytes, then the third byte, right? So this creates more complications and more wellness in the encryption process. So heading towards the mixed column, once we have done with the Gauss function, we are just multiplying it with the matrix which has been processed. But last but not the least, whatever the output has been provided, it's been XORed with the add around key to obtain the final output for only a particular round. I'm talking about the final ciphertext still. Yeah. So then this process carries out for all the 10 rounds, the last round. Yeah. Heading towards the key expansion process. In AES key expansion, the original 128-bit, whatever 128-bit we have providing in the initial stage is being divided into 432 bits. And the initial slide I have said like one word is equal to 8 bits. So we have consolidated 4 bits, which is total about 32-bit words. And each subsequent word is generated from the earlier words. Whatever the word we have generated from the earlier word, it's been given into a G function. Then that G function will be XORed and given to the initial word of the next step. I will discuss the diagrammatical part in the next slide. So the first transformation in the key expansion process is the root word, which adds the unpredictability. It determines the unpredictability and ensures that each word affects the next round of the key. Cycling, it basically means that we are cyclically rotating 1 bit at a time for each and every levels. Let it be a column wise, let it be a row wise, to provide more unpredictable data. So for these bits per bit, B0, B1, B2, and B1, B2, B3, so on, it goes on. The subword transformation, the next in the key expansion, introduces non-linearity in the AES key expansion, which uses the S box to substitute each byte in a word. To substitute a byte, we have to compare the values with the S boxes, right, to determine the subword transformation. Once the subword transformation is been done, then the add route constants is being applied, where we have to XOR the subword outputs to determine the initial byte to make it even more unpredictable. That's what I was saying in the previous diagrams and slides as well. Each and every steps are making it more unpredictable and very secure for the security purpose. The resulting whatever the G function we have got for a particular key expansion is been combined with the first word of the previous round. Then it has been XOR operation to create the first word of the subsequent round. Then it becomes the first operation of the subsequent next round. So as you can see in the diagram, that this is for the column wise, there's each words followed by its expansion keys. This is also the expansion keys, and this is a row wise process. This is the column wise process. So this each word after this word for heading towards the next word process, after the G function, this becomes the XORing formation for the next round, and it provides the next initial word for this. And for a particular word, this is the this one process, working process. The word will be bifurcated into bits. which contains the mixture of bits confusion over here. Once it has been confused, it has been compared with the S boxes. Then S box creates a new bits comparison, which will be again XORed by using a particular key, column wise or row wise, depends. It depends on what AES we are we have designed. And then the new
Sorry
word
to
will be
interrupt,
found.
sir, but you have 1 minute to conclude.
Yeah, sure, sir. So results and discussion. So we have taken about 1290 samples of 10 sets of table 1 and table 2. We can show it out. These are the samples for columns wise and the avalanche effect and row wise as well. So this is the standard graphical deviations for variance, standard deviations have an avalanche effect. So conclusion, last but not the least, we have concluded in such a way that the standard AES column-wise and new AES row-wise have both high avalanche effects and high security. But comparing with its standard deviations and all, the standard column-wise had a predominant role and a higher approach towards the results compared to the row-wise operations. As you can see, the data for variations as well, for variations for row-wise, variations for column-wise, row-wise and column-wise standard deviations, and this is the mean for the respective column and row-wise. So I conclude this presentation over here. Thank you. We can go with the Q&A section.
Thank you, sir. Now I request our respected session chair, sir. Sir, do you have any questions? Sir, do you have any questions? Maybe sir is not having any questions. Let's move towards the next presentation. For the next presentation, I would like to call Rahil for the paper title Security and Performance Analysis of Hash Algorithm with a Black Box Testing Approach. I request the presenter to kindly proceed with their presentation.
Thank you. Hope my screen is visible.
Yes, sir, your screen is visible to us.
Yeah. Am I audible as well?
Yes, sir.
Okay. So thank you. Just a minute. Yeah. So thank you and good afternoon once again. So the next paper, which is entitled, which is Security and Performance Analysis of Hashing Algorithms with a Black Box Testing Approach. I think, Black Box Testing Approach. So these are the authors, respective authors. So heading towards the introductory part, basically we have designed a black box system, and a black box system basically does not discloses the internal working. It's basically a system which does not discloses the internal working, but we are just playing with the input and output. Whatever the input has been given, it has been processed with the inside the black box and it's provided in the output section. Our study investigates the efficiency and security of various hashing algorithms like MD5, SHA-1, SHA-256, SHA-512, SHA-3250, Blake 2B, Shake 256 of 1024 bits, and an unknown SHA-256 variant. Resulting with the parametric analysis, the avalanche effect is basically refers to a property where an input change, basically a minor input change, should cause about 50% of outputs to be flipped, ensuring that it has a significant variation in the resulting hash. Whereas next is the bit independence property, requires the changing of one input bit independently. Whenever we change a particular input bit, it should at least impact about 50% of output bits to be flipped, to make sure that the minimal correlation between the bits changes. Next, heading towards the compression ratio, which determines the efficiency of the hashing function, and reducing the input data to a smaller extent and producing an output of a fixed size, which has an ideal value of less than or equal to 1, indicating the effective compression. Next, we are heading towards the uniformity, which provides the consistent and unpredictable output if it has a variance of less than or equal to 0.1%. And the hashing algorithm to have a faster speed should inculcate with the threshold value of 10 lakh hashes per second to meet the performance expectations. And also the sensitivity also should evaluate in such a way that if there is any small change in the input, will have a predominant change in the output to provide the much more sensitivity. Last but not the least is the entropy, which has the threshold consisting of 4.5 bits per bytes, which determines the unpredictability or randomness of the function's output, while speed ensures its practical application in the real world scenarios. This is the methodology which I'll discuss in the further slides, further flowchart. Yeah, as you can see, I'll just zoom it out. Yeah, as you can see, the methodology consists in such a way that the black box which we have designed asks us the input. We have to determine a very predominant input for it. Then it processes with the hashing algorithms, where you can see we have determined each and every algorithm with an unknown algorithm as well to be compared. Next, we have to calculate. Once the process has been done, it has been calculated to each and every matrix in each algorithm to calculate the compression ratio, uniformity, speed, entropy, effective, and rest all parameters. Once the parameter calculation has been done, it goes to the decision points where it is compared with its standard, with its, what do you say, threshold values, with the threshold values of the parametric analysis. And also it checks the compression ratio as well during the decision making. I have just forgot this line. Yeah, after comparing and calculating with the threshold values, it prints the result in the hashing algorithm, where the results are being calculated and formulated into the analysis of black box, and then graphs are also plot as per the analysis. Once the particular algorithm has been analyzed, an overall verdict is been given for the algorithm after the test. Yeah. So basically, this is the internal structure of working, how it is being designed. So results and discussion part. The result discussion basically focuses on examining several hashing functions to enhance its security. It also tells how the cryptographic method works and how strong the parameters are guaranteed for safe data encryptions. That the comparison table, which has been inculcated in the further slides, determines how different algorithms, how it has been working for its different parameters. Although SHA-256 and SHA-512 offers the greatest security, MD5 and SHA-1 are considered outdated despite their speed. They have a better speed, but they are outdated in today's hashing algorithms, while SHA-256 of 1024 bits and Blake 2B are recommended for modern application due to their superior security and adaptability. As you can see, this is the performance analysis for each and every algorithm based on its parametric analysis we have compared. Next, this is the analysis of the black box output. We have given the input as this number of 32-bit, and then it's calculating based on its black box and giving its encrypted output, rest of the testing parameters, and a message also, like the speed is below the threshold or something, depends on the threshold values after comparing with the threshold values. Once the data has been proceed, the overall verdict has been given, like MD5 is fast but outdated, vulnerable to attacks. So similarly with all the algorithms which has been processed, as you can see, the data has been processed. And last, we are not, but not the least, the graphical analysis. Once it has been converted, it has been compared with the graphical analysis. It provides a graphical analysis as well for each and every, parameters. The conclusion part. Last, the comparison of hashing algorithm shows that Blake 2B is exceptional as per our analysis, which is about 699,050.67 hashes per second with robust cryptographic properties, including high entropy of 3.925 bits per bytes and an excellent bit independence of 266 bits. Followed by MD5 shows best avalanche effect, 58.59%, but SHA-256 of 1024 bits achieves the highest entropy of 3 among all the algorithms, hashing algorithms, of about 3.9416 bits per byte, despite being slower in speed. As comparing the entire results, we are coming to a conclusion or suggestion that the Blake 2B is best suited for the high-speed applications, while SHA-256 and SHA-256 of 1024 bits are better suited for enhanced security needs. Whenever we compare with the security purpose, we can go for this Algorithms, if we are consideration of the speed, we can go for Blake 2B. Future scope of this project is that we can focus on improvement of efficiency and security, particularly in upgrading the SHA-3, 256, which is the CACAC function, and the Blake 2B for their robust security features. Lightweight hashing functions are also crucial for the IoT security, with potential improvements to defend against side channel attacks, and also it supports post-quantum cryptography. So I end my presentation over here. Thank you. We can go with the Q&A section.
Thank you, sir. Now I request respected session chair, sir. Sir, do you have any questions? I request my respected session chair, sir. Sir, do you have any questions?
Hello. Hello.
Yes, sir. You are audible to us.
Yeah. Continue. No problem.
Yeah.
No question.
Okay. Thanks. Thank you.
Okay, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Kritika A for the paper title Smart EB Meter, Digitalization of Reading and Bill Generation. I request the presenter to kindly proceed with their presentation.
Good morning, everyone. Sorry,
Good
good afternoon,
morning.
everyone. Sorry, sir. Good afternoon, everyone. I am Kritika Anbalahan from Sri Sairam Engineering College, Chennai, and I am executive present our project titled Smart EB Meter, Digitalized of Reading and Bill Generation. This project focuses on automatic electricity meter reading and bill generation to make the process efficient, accurate, and user-friendly through IoT Arduino technology. Currently, traditional electricity meter billing systems are manual and prone to errors, causing inefficiency. Our smart EB meter offer a modern solution that track energy consumption in real time and automate bill generation. Also, ensure secure UPI-based payments. With this, we aim to improve the overall energy management system for both customers and utility providers. Here the objectives are. The main objective of this project are to automate electricity meter reading and billing and provide real-time monitoring for consumer to minimize billing errors and disputes, and also offer a securable and scalable transparent solution for energy management. Here the proposed system. Our system integrates hardware and software for seamless energy monitoring and billing. Here the hardwares are ACS 712 sensor is to measure voltage and current. Arduino process the data and send it to via ESP32 to the cloud. Here the software systems or the data is stored in the cloud and processed for billing system. Here we integrated a mobile app. It is used to allow to view usage, receive alerts, and pay bills via UPI payment system. The system ensures accurate data collections, smooth communications, and user-friendly interactions. Here the working mechanism. The process involves is 4 key steps. First step is data collection. Is the sensors collect the voltage and the current sensor from this respective sensors. Here we use ACS 712 current sensor. The second step is data processing. Arduino process the data which is transmitted via ESP32. The third step is cloud mobile application with integrated with the cloud integration. Data is stored and processes on platform like render platform. Here, the final step is user interaction with the payment gateway. It consumes the app to monitor usage and pay the bill in secure way. We tested the system in several stages. The first test is initial stage. We used an LCD to display real-time voltage, current, and power data. And cloud connectivity, the data was successfully transmitted to the cloud in real time. The third step is the mobile app integration testing. The app displayed accurate usage data and billing information. Here, the final step is the system handled multiple users smoothly and provided scalability without delays or crashes, ensuring scalability for future deployments. This is the overall prototype. And it is a app we created. The main advantage is the real-time energy tracking helps a user control consumption. Also, automated billing eliminates manual errors. The UPI integrated makes payments quickly and easily. Utility provides benefits from increased efficiency and transparency. The challenge and while we integrated this type, we faced some challenges. It was in the initial calibration for sensors for precise measurements, also maintaining stable Wi-Fi connectivity for real-time data transfer. For future enhancement, we are adding voice commands features for convenience, displaying energy consumption trends through graphs, providing push notification for time alerts. In conclusions, for our smart EB meter transform energy billing by offering accuracy, transparency, and ease of use. It represents a major step towards smart energy management system for homes, business, and smart cities. And finally, thank you for your attention. I'm happy to answer any question.
Thank you, ma'am. Now I request our respective session chair, sir. Sir, do you have any questions? Okay, let's move towards the next presentation.
Thank you.
Thank you, ma'am. For the next presentation, I would like to call Rahil for the paper title Statistical Assessment of AES Analyzing Entropy, Correlation, Coefficients, and Frequency Distributions. I request the presenter to kindly proceed with their presentation.
Yeah, thank you. Let's hope the screen is visible. Yep. I hope the screen is visible.
Yes, sir, the screen is visible.
Okay, thank you. So yeah, the next title which I'm going to represent is Statistical Assessment of AES Analyzing Entropy, Correlation Coefficient, and Frequency Distributions. So basically heading towards the introductory part. In cryptography, we have leveraging the concepts of entropy, correlation coefficient analysis, and frequency analysis in safeguarding the data security, secrecy, integrity, and authenticity in the today's digital world. Entropy is basically measuring the uncertainty in the data, or we can say the randomness in the data, which is very crucial for the cryptography for securing keys, encoding data, evaluating randomness to enhance the resistance against the brute force attacks and unauthorized access. Basically, next we are heading towards the correlation coefficient analysis. It is a very key tool in cryptanalysis, which identifies the statistical relationships between the plain text and the ciphertext, basically uncover the patterns of vulnerabilities that can inform decryption strategies and improve the security. Last but not the least is the frequency analysis remains the foundational technique in cryptography, which enabling helps the analyst to encrypt the message by decoding it and examining the character distribution in the ciphertext, revealing the vulnerabilities in the cryptographic system. What are the problems in the cryptographic systems? This frequency analysis helps to analyze. Next, we are heading towards the implementation details. AES is that we are implementing based on ES, which helps in measuring the entropy for randomness, coefficient correlations to detect the linear relationship between the plain text and the ciphertext, and analyzing the frequency distribution to access the uniformity in the encrypted outputs. So this is the entropy formulation, and it is defined as the degree of randomness with the collection of informations. As high the data entropy in cryptography, which helps us prevailing that it is more unpredictable and random, enhancing, which also helps in enhancing the security due to various types of attacks like brute force attacks or cryptanalysis attacks, while low entropy reveals that the patterns of the ciphertext are vulnerable to attacks like frequency analysis, weakening the encryption strength. Heading towards the correlation coefficient, which statistically measures the connections between the ciphertext and the plain text to reveal what is the weakness in the encryption system. That is formulated by the R is equal to covariance divided by the standard deviation. So basically, if the correlation coefficient has a positive one value in cryptography, which denotes that it's a perfect positive correlation, which means that the variables in the plain text and ciphertext will either be synced in a increasing manner or be syncing in a decreasing manner. It is directly proportional to each other. Whereas if the data value is in -1, which is inversely proportional, one increases, other decreases. Similarly, if we go with the little correlation, which highlights the patterns of flaws in cryptanalysis, but a weak or non-existent correlation has a value, R value closer to 0, which indicates that it has generally no link or a little link to it. So last but not the least is the frequency analysis. Basically examines the frequency of letters or symbols with the ciphertext, whatever the output we have obtained, how many types of particular symbol or a letter has been presented in the ciphertext, which exploits a certain letters or combination occurs more frequently in most of the many languages. So formulated as count of the ith ASCII character, it basically determines the ASCII characters in C determined by n, what is the length of the ciphertext. Repeated number of this one symbols divided by n. This basically gives us a proportion of occurrences, how many characters are relative in the total number of characters in the ciphertext. Due to it has intricate operations in the plain text blocks, modern block ciphers like AES are intended to withstand the frequency analysis. But yet we get some implementation errors while to reveal some of the weaknesses during the AES process. So heading towards the results and discussion. The results of AES highlights higher entropy and near to zero coefficient correlation, which shows the robustness of randomness and minimal linear correlations between the plain text, the input, and the ciphertext, the output. We have determined about 1,290 samples where the samples has been measured in the x-axis and the entropy values has been determined in the y-axis. As you can see in the entropy analysis, we have compared the samples and of rows and we have compared into columns. And by comparing entropy of rows and columns, we have predominantly constructed a table which says about the avalanche effect of mean, standard deviation of variance of the entropy, which has the values initiated by rows and columns, standard deviation of rows and columns, and variance of rows and columns. So heading towards the correlation coefficients, the similar process has been indicated, but we are calculating the correlation coefficients to determine the comparison between or statistical analysis between the plain text and the ciphertext, which I'll show in the further slide in the tabular column. What are the values? So this is also the rows and correlation column, which we have compared and analyzed in the last graph. And we have tabulated the rows and columns value for mean, standard deviation, and variance. So last but not the least is the frequency test. In frequency test, we have got a graphical analysis of histogram based on its ASCII values of plain text. The x-axis determined the ASCII values ranging from 0 to 255 and y-axis shows the frequency. So heading towards the graph, to show it very simpler way, the whatever the plain text is nothing but the inputs. The inputs is been converted into an encrypted text or cipher text due to a process of encryption and decryptions. To determine whether the cipher text or the data, the data has been encrypted in a very successful manner, the histogram which is provided in the decrypted cipher text histogram, as you can see in the graph, and the plain text should match the graphs to determine the successful encryption standards. If the graphs does not match, then it is understood or determined as the encryption process has not been done in a very successful manner for frequency tests. So heading towards the last but not the least, the conclusion. The study explores how entropy, correlation coefficient analysis, and frequency assessment in encryption algorithms help to monitor the data for determining unpredictability, decoding patterns, and identifying the encryption vulnerabilities. Frequency assessment is basically a key technique for decoding encrypted messages, enhancing the data security, contributing to various insights on ongoing cybersecurity, and encrypting discourse of experts and decision makers. This is a very valuable aspects and test for various uh, parts in the cybersecurity, various designations in the cybersecurity. Regarding of the future scope, the future studies might concentrate on creating sophisticated cryptographic approaches that can use entropy, correlation analysis, or frequency evaluation for different algorithms as well. This is just done for ES, but for different algorithms, it can be also tested and performed based on its particular requirements. Furthermore, we can examine the integration of machine learnings, encrypt analysis, quantum and post-quantum cryptography, and the convergence of blockchain technology and cryptography. So these are some of the future scope which can be inculcated to be tested and analyze the data and process of encryptions. So I end my presentation over here. We can go ahead with the Q&A section. Thank you.
Thank you, sir. Now I request our session chair, sir. Sir, do you have any questions? I request the presenter to kindly proceed with their presentation.
Is my screen visible?
Yes, sir. Your screen is visible to us.
Okay. Okay. Yeah. Good afternoon, esteemed members. My name is Sahil Taishete, and I am honored to present our survey paper titled Technological Innovation in Digital Payments. This is a collaborative effort of all, along with my co-authors, Preksha Shah, Dr. Jaipriya J, Dr. Vinay M, Dr. Deepa S, all from Christ deemed to be University, Bangalore Yeshwanthpur campus. We like to shed a light on the evolving digital payment landscape in today's generation. The presentation provides a comprehensive overview of our study covering the background, objectives, and key insights. It includes a review of literature to identify research gaps, a detailed methodology, and an exploration of findings categorized into trends, challenges, and opportunities. The discussion highlights implications of the future directions, conclude with a summary and the acknowledgements, offering a holistic view for our research journey. So, talking about the digital payments, in the digital payments have currently transformed the whole payment systems, especially with the during the COVID period where there was a big need for non-physical payment systems. So that and this technological innovations have been fueled by the AI innovations in AI and fintech, which have driven this whole evolution of digital payments. So, but even in with these innovations, there are some challenges faced with these innovations, like the adaptation of of these systems in the rural areas. Hence, that has given rise to a problem statement: unequal access to digital payment systems due to infrastructure gaps, literacy, and cybersecurity issues. And we also aim to complete the objectives of to explore the trends, challenges, and opportunities in digital payments, also analyze the role of AI and fintech in bridging gaps and promoting inclusion policies. Our literature review consists of very prominent papers which have addressed the JAM Trinity and financial inclusions, have also been given an overview of how the payment adoption is in progress in the current youth generations, and also the role of fintech in the MSME governance. But even in spite of these prominent papers, there are still some research gap that can be addressed. There is a limited studies on the impact of emerging technologies like blockchain, which can be used to make a decentralized financial apps. And also there is insufficient focus on the rural and underbanked regions of India. The methodology used for our study is a mixed methods, which is consisting of qualitative and quantitative analysis. The um, the data that we have been used for apply the different AI models is been acquired through the payment systems such as RTGS, NEFT, UPI, and also the global indicators like IMF. The tools used for the applying to do the analysis are the AI based tools for fraud detection, transaction predictions, and also we have applied some statistical methods for demographic and regional analysis. Key findings from the key findings, the trend that has been going on to for the digital payment systems is been the rapid and massive adoption of these technologies in the urban areas, and the same slow and lag behind growth in the rural regions. The increased use of blockchain and AI technologies has been started in the last 6 or 8 months, and which have been these technologies have been used for fraud detection and data security for its prominent uses. This the inclusion of all these technologies have given rise to cross-border payment systems and also mobile wallets, which has helped for international transaction, which is with a very robust security system and also a very quick process. Talking about the insights, the India's UPI system has actually revolutionized and has set a benchmark for various other cashless economies. And the innovations in decentralized finance, which is DeFi, using the blockchain technologies, are reshaping the payment ecosystem, as it does not have a centralized person or a company which is overviewing the whole payment systems, but it's actually it is not it has been uh, free from defrauding and scams. The challenges faced during our studies were in the that have been found in the digital payment systems is the infrastructure gaps in rural areas. The adaptation has been very slow, and in some areas have not been there because of the poor internet connections or low digital literacy rates. The cybersecurity concerns have created a user trust issues, which has slowed down to the adoption of these new technologies to some extent. The regulatory hurdles of fintech and technologies have been a constant issue, as the policymakers are not able to keep up with the new innovations, and hence has slowed down the regulation and the security breaches, and has led to the slowing the innovations of these different technologies. The opportunities in this domain is countless. So the AI driven financial inclusion solution systems have been the arrowheads of these new era. The integration of AI in securing the data of these payment systems, and also securing the security and proof from cyber security, has led to the great several innovations, and hence have been the force for the new innovations in this field. Blockchain enabled apps have also been the core of the various DeFi apps, which have been provided a decentralized systems for creating various digital systems. If the policy reforms have been established properly, the adoption and innovation can be increased to a even faster rate. Talking about the model analysis for our paper, we have implemented various AI ML models, of which random forest and LSTM have been the most prominent and most accurate models for detecting fraud and transaction analysis. Blockchain also reduces the transaction cost and enhances transparencies and have shown a similar accuracy rates. The use of AI-based models have showed a 35% improvement in the fraud detection, and hence has increased the users' trust into these systems. Now, coming on to the conclusion, uh, the digital payments are pivotal drivers of economic growth and financial inclusion. Technologies such as AI and blockchain enhance the efficiency, security, and accessibility. Making financial systems more robust and inclusive is the main aim of the should be the main aim of the current policymakers. However, challenges like rural adoption barriers, cybersecurity threats, regional disparities, required target interventions have always been are going to be present. Future efforts should be made to emphasize enhancing infrastructure, strengthening cybersecurity, and fostering collaborations among the stakeholders to build a robust data secured model and to also improve the adoption policies by the government. Hence, this study has provided a valuable insights into the digital payments into digital payments landscape and lays the groundwork for future research and policy development. In conclusion, I extend my heartfelt gratitude to my co-authors, collaborators, and the organizers of this esteemed conference. Thank you for your attention, engagement, and I'm open to any further inquiries or questions that you might have.
Thank you, sir. Now I request our respected session chair, sir. Sir, do you have any questions? If any of the participants has any questions, they may also proceed. Okay. So now we are moving towards the next presentation. For the next presentation, I would like to call Chukvunoso Henry for the paper title UML for ABM, a case of malware spread in wireless sensor networks. I request the presenter to kindly proceed with their presentation. So let's move towards the next presentation. For the next presentation, I would like to call Karodya Kunj for the paper title Bridging Traditional Techniques and AI-Driven Approaches in Image Deconvolution from Classical Approach to Cutting Edge Techniques. I request the presenter to kindly proceed with their presentation.
So my screen is visible?
No, sir, your screen is not visible to me.
I have sent the request.
Sir, if you're facing issues regarding screen sharing, you can share me the PPT via chat. I can share it on your behalf. Yes, sir,
Now
now
it
it
is
is open.
okay. Thank you. Just a minute. Now it is fully visible, right?
Yes, sir.
Okay. So good afternoon to all dignitaries present over here. I myself, Kunj Koradia, the author of a paper ID 281, Bridging Traditional Techniques and AI-Driven Approaches in Image Deconvolution. So let's move further. So image deconvolution. Image deconvolution is computational technique designed to reverse the degradation of images caused by blurring. Blurring can occur due to the several factors such as motion, defocus, atmospheric conditions, or the imperfections in image system. The process involves estimating the blur kernel, a mathematical representation of the blurring effect, and applying algorithms to the reconstruct a sharper and more detailed image. This restoration process is critical for extracting the meaningful information from the degraded visual data. And there are a lot of different types of blur available while capturing the image: motion blur, defocus blur, Gaussian blur, average blur, and radial blur. When we talk about the blur, there are total two types of blur, blurifications we can apply onto the images. First of all is a synthetic blur, and another one is blind blur. So before that, I would like to say that what is the meaning of deblurring. So image deblurring, also known as an image deconvolution, is the process of restoring clarity to a blurred image by reversing distortion caused by motion, defocus, or other factors during capture. It involves estimating the original sharp image and, in some cases, blur kernel responsible for the restoration. This technique is widely used in photography, medical imaging, and astronomy. So there are two types of blur we can apply onto the image. First of all is synthetic blur. Synthetic blur refers to the artificially added blur to image using predefined mathematical models or kernels such as Gaussian blur or motion blur. It is commonly used in research and development to test and evaluate image deblurring algorithms. Since the blur parameters are known, it provides a control environment for the performance benchmarking. While talking about the blind blur, it occurs in the real-world scenarios where the nature and parameters of the blur are unknown. It poses a greater challenge as the both originally sharp image and the blur kernel need to be estimated simultaneously. Blind blur is common in photography, surveillance, and scientific imagination. In synthetic blur, there are two types of approaches we can follow. First is traditional approaches, and another one is frequency domain approaches. In traditional approaches, it uses in synthetic blur oftenly rely on algorithms like Wiener filtering and Richardson-Lucy deconvolutions. These methods are predefined blur kernels to reverse the effect of blurring. They are effective in control scenarios where the blur parameters are accurately known. While talking about frequency domain, and these methods analyze and restore images by transforming them into frequency space using techniques like the Fourier transform. Synthetic blur is represented as a convolution in the spatial domain, which become multiplication in the frequency domain, simplifying the deblurring process for the non-blur kernels. While talking about in blind blur, there are two. First of all is optimum models and the deep learning models. So in the optimization models for deep learning involve formulating the problem as the mathematical optimization task where an objective function is minimized to recover the sharp image. Techniques like total variations, which is also known as in TV, regularizations, and sparsity constraints are used to enforce smoothness or to preserve the image edges. These models rely heavily on iterative methods and work well when the blur kernel is known or estimated. Deep learning models. Deep learning models uses neural networks such as the CNN convolution neural networks to learn the mapping from blurred to sharp images. Models like UNet, DBlur, GAN, and HNet are trained on large datasets to handle complex and real-world blur scenarios. They excel in performance and generalization compared to the traditional methods, especially for the and dynamic deblurring. So in methods, there are total three types of methods we've been using: Wiener filtering, Richardson-Lucy algorithms, and total variation regularization. Wiener filters, it reduces noise, works well for the simple blur patterns. Richardson-Lucy algorithms handles Poisson noise. Noise is a term when the image gets the noise from the deflection of light. It is an iterative method. Total variation regularization preserve edges while reducing the noise. The limitation of these traditional methods are struggle with the noise and complex blur. Removing the noise is one of the critical tasks in image deblurring, and these methods cannot able to handle the complex blur, and it is also computationally intensive. So to overcome these methods, we've been using AI-driven approaches where we use the deep learning models CNN and GN. The CNN feature extraction of the CNN is good due to its convolution layers, and GN General Advanced Network DBlur GN. It is good to improve the image clarity. It preserves the image quality. The advantages of this: it handles the diverse and complex blur patterns, which is one of the main overcomes where we are not able to get into the traditional approaches. Better noise suppressions and detail preservation. Either we could preserve the noise and we could remove the detail preservations, or either we could preserve the detail and remove the noise. And the proposed architecture is a DCGN where we need to give the images to the generator. It will generate the images, and it generates the images just like to the real images, and the discriminator will compare the generator discriminator will compare the images generated by the generator and the real images. So over here, the discriminator loss should be high and the generator loss should be low. The output of our implementation is this is the blur images that we have been fed to our model. This is the ground truth images, and these are the deblur images that we have been getting. Evolution matrix we've been using is SSIM and PSNR. SSIM we are getting 0.84, and the PSNR we are getting 25.51 over 30 epochs. We've been using the Cipher 10 as a data set. And challenges in our here challenges we get to know that we are getting high computational demands, depends on the large and the diverse data set, balancing noise suppressions with the detailed preservation. Future scope, when talking about the future scope, attention mechanism for complex blur is quite high. We are getting lightweight models for the real time application. Lightweight models are designed to perform efficiency with reduced computational resources, enabling real-time deep learning for applications like video processing or mobile devices. Self-supervised learning to reduce the reliance on labeled dataset. So self-supervised learning allows models to learn useful features from the unbalanced data by creating proxy tasks. Thus, it reduces the need of large annotated datasets in the image deep learning task. So in the conclusion, I would like to conclude that this model was built to address the limitation of traditional deconvolution methods by leveraging deep learning techniques. The amount of deep learning we are getting in traditional deconvolutions, we are getting much higher into the deep learning models, which was then AI-driven approaches. It aims to enhance image clarity and fidelity, enabling accurate analysis interface. And these are the references that we've been used in our model. So that was my time. Thank you. Let's head towards the if anyone has a doubt.
Thank you, sir. Now, I request our respective session chair, sir. Sir, do you have any questions?
Yes, Kunj, can you show me your title, please?
Okay, sir. Just a sec.
Yeah.
It is visible, right?
Yes, yes. Okay. So have you tried just only CNN model or some another model that you have implemented?
No, sir. We have used the GN model, DCGN.
DCGN, though why not CNN?
Sir, actually, we were trying to compare the CNN and DCGN model, and we are getting a little bit more accuracy in GN model. We are trying to combine the GN with, CNN with the UNet model. So the further implementations of our image deep learning is going to be on UNet model.
Okay. So can you tell me what are the other deep learning models are there except
Sir,
CNN? Yeah.
Sir, there is a vision transformer also model we've been started implementing on. So that is one model that can be used in the image deep learning.
Okay. Likewise, have you ever tried Inception V3 model, ResNet 15 model?
No, sir, we are not aware about that, but
Okay.
definitely, sir, as you said, we are going to.
Yes,
We'll look
yes,
out
sure,
on that.
sure. You have to see and you have to implement all those models so you can compare your results with
Yes,
other models also. Fine.
yes, sir.
Okay, okay. Good.
Thank you, sir.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Jyoti for the paper title, Building a Digital State, Strategic Role of Information Technology in Advancing E-Government Services. I request the presenter to kindly proceed with their presentation. If presenter is facing some issues, it's okay. Let's move towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 9th version and all the previous 8th version of the conference. We'll be happy to have you in the 10th version in 2025. All the presenters would be getting their digital certificates, within 2 working days. Further, all the papers have already forwarded to Springer for publication. The publication will be live within 6 months. Now, I will extend my heartfelt gratitude towards our session chair for chairing the session. Sir, this is the token of appreciation from GR Foundation and partners for chairing the session. I request you to please address our participants.
Thank you so much, sir, for the appreciation. Before saying something like, so I would say sorry first because I went for the meeting also in between. Principal called me, so I went there. Okay, so all the participants, many congratulations, and you have a different number of titles, and that are the innovations from your side. And I have seen all the presentation except some. So I'm having some idea about the tools and technology which you have used. Fine. So as I told you earlier, it's just a kind of interaction, sharing the knowledge, fine, in between all the number of peoples. So just I want to say, like, all the participants have present their work in a good manner, and we have a good time over here also. So thank you very much from all the teams and the ICTIS global conferences. Okay, thank you, sir.
Thank you, sir. Thank you for such motivating and kind words. Now, I request everyone to kindly turn on their cameras for a quick virtual snapshot. I request everyone to kindly turn on their cameras for a quick virtual snapshot. Thank you, everyone. Stay safe, stay connected.
Okay, thank you, sir.
Thank you, sir.
Yeah.
And I request Jyoti ma'am to kindly mail your conference presentation video to the conference mail ID.